Hi, this video is part 2 of series, Method of Difference. When do we use method of difference? When it's one of the following examples that I'm going to show you. Example 1, when it's multiplication of fractions, where we can't use the normal formulas for summation. When it's a trigonometric summation, or when it's a factorial summation like this. Take note that n factorial is actually n times n minus 1 factorial. For example, 10 factorial is 10 times 9 times 8 times 7 all the way to times 1. Now I can leave the 10 out, and 9 times 8 times 7 all the way to times 1 is actually 9 factorial. So we can see that n factorial is actually n times n minus 1 factorial. Now for example 1, we have summation of fractions. In this case, it's 3 over r plus 1, taking 1 to infinity. So when we are summing 1 to infinity, remember we have to take the finite summation 1 to n, and we let n tends to infinity. We repeat the series here. Now for fraction series like this, we need to speed it up using partial fraction. So we let 1 over r plus 1 be a over r plus b over r plus 1. And we will have 1 equals to a r plus 1 plus b r. If you're not familiar with partial fraction, please take a look at my next video on partial fraction. Let r be 0. We have 1 equals to a, 0 plus 1 plus b times 0 just be 0. We'll have a equals to 1. Let r be minus 1. We'll have 1 equals to a, minus 1 plus 1 will just be 0, plus b times minus 1. We'll have b is minus 1. So therefore 1 over r plus 1 is 1 over r minus 1 over r plus 1. Now let's consider the finite summation first. 3 over r plus 1. It will be the same as taking out the constant 3, summing r from 1 to n, 1 over r minus 1 over r plus 1. I've just replaced the 1 over r plus 1 with the partial fraction here. Now, you can recognize that this is method of difference because there's a minus sign between the two terms, or any number of terms if you have a minus sign in there. So we let r be 1. When r is 1, I have 1 over 1 minus 1 over 1 plus 1 will be 2. Right in the next row, when r is 2, I have 1 over 2 minus 1 over 3. Usually we'll write about 3 to 4 rows. 1 over 3, this is when r is 3, minus 1 over 4. All the way, I'm going to write the last 2 rows. Stop. Okay, I'm going to write the last 2 rows here, which is 1 over, when r is n minus 1, will be 1 over n minus 1 over 1 over n. When r is n, will be 1 over n minus 1 over n plus 1. You notice that we can start cancelling rows. Minus half with half, so we cancel this way. Minus 1/3 with 1/3, cancel this way, and so on and so forth. We realize that we can cancel everything except for the first and the last term. So the answer will be 1 minus 1 over n plus 1. Now we are taking limit of n tends to infinity, summation of r equals 1 to n, 3 over r plus 1. So taking limit, when n tends to infinity, 1 over n plus 1 will become very small, because 1 over very big will become very small, almost 0. So when we take the limit, it will just be 3, and that will be the answer. Now on to example 2, we have trigonometry summation. Now in this case, when we have multiplication on trigonometry, it's easier to speed them up using factor theorem. Recall that for factor theorem, we have cosine p minus cosine q is minus 2 sine half p plus q sine half p minus q. Okay, now let cosine p minus cosine q be minus 2 sine, what do we have? R plus 1 theta here, so r plus 1 theta, and sine theta over 2. So we compare these two, we can see that this is this, and this part is this, right? So we have half p plus q equals to r plus 1 theta. That gives us P plus Q. We have P plus Q equals to 2r theta plus 2 theta. After I expanded up, bring up the 2. And for the next one, I have half P minus Q equals to theta over 2. The 2 can cancel off, leaving me with P minus Q equals to theta. Now, we have a simultaneous equation here. I'm just going to add the first one to the second one. I'll get 2P, because my Q will cancel out. 2r theta plus 2 theta plus theta will be plus 3 theta. So my P will be r theta plus 3 over 2 theta. If I were to factorize the theta, I'll have r plus 3 over 2 theta. That's my P. For Q, I can look at the second equation here. Q will be, if I move the Q here, my theta will be moved here. Q will be P minus theta. I'm going to use this P here, which is r theta plus 3 over 2 theta minus theta. I'll get r theta plus half theta. Factorize out the theta, my Q would be r plus half theta. So now we found our P and Q. So we have cosine P minus cosine Q, which is actually the after we have split up from the multiplication of the sign. So we have minus 2 sine r plus 1 theta sine theta over 2 will be cosine P, which is cosine r plus 3 over 2 theta minus cosine Q. Cosine Q will be this one, r plus half theta. So now we are ready to do our summation. Notice that the minus 2 is here, but in our summation we do not have a minus 2. Simply bring the minus 2 over to this side. So I will have this sine r plus 1 theta sine theta over 2 will be minus half of this entire thing, cosine r plus 3 over 2 theta minus cosine r plus half theta. Okay, so this is what we have when we sum r equals 1 to n sine r plus 1 theta sine theta over 2. We're actually summing the speed up version, which is minus half here, cosine r plus 3 over 2 theta minus cosine r plus half theta. When r is 1, again we notice it's a matter of difference, that's why we let r be 1. So we'll have cosine 1 plus 3 over 2 theta will be 5 over 2 theta minus cosine 1 plus half will be 3 over 2 theta. Next line, when r is 2, we'll have cosine 7 over 2 theta minus cosine 5 over 2 theta. When r is 3, we have cosine 9 over 2 theta minus cosine 7 over 2 theta. All the way to the last two lines, when r is n minus 1, we'll have cosine n minus 1 plus 3 over 2 theta minus cosine n minus 1 plus half will be n minus half theta. When r is n, we'll have cosine n plus 3 over 2 theta minus cosine n plus half theta. Now notice we can cancel off again. This time around we're cancelling this way, so on and so forth. So will be minus 1 plus 3 over 2 will be plus half, which will be this. So we can cancel off here all the way. So we're only left with minus half cosine n plus 3 over 2 theta minus cosine 3 over 2 theta. And we're done. And for our last example will be summation of factorial functions. In this case, we have to show 1 over r factorial minus 1 over r plus 1 factorial is 1 over r minus 1 factorial r plus 1. Typically, when you see questions like this, it's a matter of difference because there's a minus sign here. So let's show first, left hand side. 1 over r factorial minus 1 over r plus 1 factorial. Let's do a common base first, which will be r plus 1 factorial. Now, why did I choose r plus 1 factorial? Because r plus 1 factorial is actually r plus 1 r factorial. So you see the r factorial is already inside here. So what is lacking off in this component here in this term here will be just a r plus 1. So it will be a r plus 1 minus 1 here. So this cancels off, leaving us with r over r plus 1 factorial, which I can change it to r plus 1 r minus 1 factorial. Now because r plus 1 factorial is actually r plus 1 times r factorial, but r factorial can be split again into r minus 1 factorial. So I can cancel off my r, leaving 1 over r plus 1 r minus 1 factorial, which is the right hand side shown. Alright, now let's sum from r is 1 to capital N, 1 over r factorial, r plus 2 factorial. But take a look. This does not really look like the one above here. There seems to be some replacement here. So we let u be r plus 1. Therefore, r is actually u minus 1. Now for here, when r is 1, u is 1 plus 1 is 2. When r is n, u will be n plus 1. Now we're going to totally replace this series using u instead of r. So summation of r equals to 1 to n over 1 over r factorial r plus 2 is actually summation of u equals to 2, because when r is 1, u is 2. When r is n, u is n plus 1. 1 over, now r factorial will become u minus 1 factorial, and r plus 2 will become u minus 1 plus 2. This gives us u equals to 2 to n plus 1, 1 over u minus 1 factorial, and this one will become u plus 1, which looks exactly as the one above here. So now I can replace this with the result that we had shown earlier. Okay, let's do it now. So let's just repeat this. Summation r goes 1 to n, 1 over r factorial r plus 2 is really this. Summation of u is 2 to n plus 1, 1 over u minus 1 factorial, u plus 1 u plus 1. So let's just write the upper and lower limit here. So 1 over u minus 1, u plus 1 will be replaced by this one over here, which will be 1 over u factorial minus 1 over u plus 1 factorial. Okay, now we're almost done. Method of difference now. When u is 2, we will have 1 over 2 factorial minus 1 over 3 factorial. When u is 3, we'll have 1 over 3 factorial minus 1 over 4 factorial. When u is 4, I have 1 over 4 factorial minus 1 over 5 factorial, all the way to my last two terms. When u is n, I'll have 1 over n factorial minus 1 over n plus 1 factorial. And when u is n plus 1, 1 over n plus 1 factorial minus 1 over n plus 2 factorial. Now we can start to cancel again. All the way, I'm left with 1 over 2 factorial is just half, minus 1 over n plus 2 factorial. And we are done. Thank you for watching. See you next time. Thank you for watching my video. If you are interested to learn more, please subscribe to my channel. Till next time.